Okay, welcome function folks. This is a lesson on transformations. Mostly review, but we'll see that there are a few little new twists on what you remember from grade 11 because our textbook handles things in a slightly more mature way because you're slightly more mature mathematicians, I suppose. State the transformations. What are we talking about here? Well, this one is the parent function for a parabola, so they must be talking about g. And what's a little bit different here is we've never really seen, or not very much at least, from a grade 11 as one function as another function transformed. So g is whatever f is with these transformations. And what are the transformations? Well, that's what our task is in part A. The -2 in with the x, in the direction of x, it's opposite that. You think -2 would go left 2, but this is right 2. And the half isn't in with the x, so it must be affecting y values. This is a vertical something, and since it's a half, it's a compression. Remember, in the direction of y, it's what you think it should be. So multiplying by a half should compress it or should squish it, and it does. All right, so part B. Whoops, I'm already ready to graph it here. I'm getting ahead of myself. Write an equation. So what this is saying, it says, okay, we've got an equation here, but we know what f is as well, so we can write g as an equation not in terms of f, but in terms of the parent function. And the parent function x squared, that's been vertically compressed by a factor of a half, is there, and moved right 2. Since the parent function is the parabola, we can do that. And when we get to the graph, there's a number of ways that you could graph it. You could just use your grade 10 techniques, I suppose. But I'm going to talk in terms of transformations that you learned in grade 11. So I'm going to start with the original one, even though you might not need to. So the original one, and I'm doing a nice, clear, obvious mark, whether it's a dot or a check or an X here. And then over 1, up 1, over 1, up 3, 1, 2, 3, dandy, over 1, up 1, over 1, up 3 is the basic shape. However you remember the basic shape of the parabola, that's what we need to draw. Try and draw a nice smooth curve through there. That's not great, but not terrible. Okay, so that's my basic one. And generally we do the stretches and squishes first. So I'm going to do the vertical compression. So what does that mean? It means all of the vertical distances get cut in half. So how far up the parabola goes gets cut in half. Well, this point, and I like starting at the vertex, is 0 units off the x-axis, so it stays put. A half of 0 is still 0. Half of 1 is a half. A half of 4 is 2, right? That distance was 4, and it gets cut in half, so that's 2. And I do the same thing over here. In grade 10, we would have cut our step factor in half, but when we just think of any vertical distances getting cut in half, we can think of transformations more in general. Notice we're not done yet. We haven't moved this red one to the right, and that's what my last step is to do. And I could do that by moving each of my nice points right 2. Or I could move the vertex, the starting spot, and then look at the pattern. Over 1, up a half, over 1, up 1.5. And either way, I'm still going to get the same graph. Move all the nice points over 2, and I get the same squished parabola. And there's my end graph, y equals g at x, or I could label it with its equation, a half x minus 2 squared. Good. Hopefully that's review for you and some transformations. We're going to get lots of cracks at the transformation this year, but this first point of the lesson is something that's a little bit new. The textbook handles transformations in a little bit of a different way. They call it a mapping notation or a mapping transformation. The idea of if we have g at x equals a half f at x minus 2, this is from the 3-minute review again, then what we're thinking of is we're kind of thinking of a pattern, a formula to get from f to g. If I have a point x, y that's on f, where does it end up on g? Well, I said that the half, squish the y coordinate by a factor of a half. So the form, whatever y is, I'm just going to divide that by 2 and multiply by a half, and that's my new equation. Similarly, in the direction of x, I'm moving it right too. So whatever the x is, what's the new x? Well, it's been moved right too. And this is kind of like a formula for points that are on G. And so then they just go ahead, and they being our textbook, go ahead and say, well, what are some points that are on F? Well, we got a bunch of points on F here. Why don't we just list off a few of them? Why not? There are some points on F, so what would those points be on G? Well, now that I calculated a formula for all the points, all I have to do is fill them in. 9 times a half is 4.5, and -1 would be 1.5. And these points here are probably points on our function from the 3-minute review. 2, 0, 5, 4.5, 2, 0, yeah, 2, 0, 5, 4.5 would be over here, but yeah, it would be on there. -1, and what did we say? No, not -1. What was the last point? 1.5. Oops. 1.5. Yep. And then in this way, this is how our textbook handles transformations. Rather than thinking about transforming the graphs, they transform the points. And we'll see later in this lesson and throughout the course that there's an advantage. For the most part, I'll think of the graph, just like you did in grade 11. All right, how are we doing for time? I think I might pause this and pick it up in 7 minutes. Can we do a whole example in 7 minutes? I'm going to pause it there, and we'll pick it up in part 2.